Hi guys, so here we have part 2, chapter 3, basic reactivity. All right, so this is the second half of chapter 3, and we are covering two additional concepts in reactivity. Again, reactive programming means that output is responsive to inputs, right? Every time the user changes input, output reacts to them, right? And therefore reactive programming, right? So here, the first concept is the theme here is how often Shiny updates. So it updates because it reacts to changes in inputs, right? So we can control the frequency of Shiny updates. So there are two ways, two different situations that is discussed in the textbook. One, we use current time as an input to control the pace of Shiny updates. Second situation is we use users clicking on button, right, as an input to control the pace of Shiny updates. And the last topic here is observers. So observers are situations where we use reactivity to do something other than um, creating tables, creating graphs, right? An example that's discussed in the textbook in chapter 3 is to send a message to the console. All right, so let's take a look at the concept more in detail. All right, so here we have a table of two columns, one on the left in orange. Um, this is a situation where we use current time as an input to control Shiny updates, the frequency of Shiny updates, right? So this is more appropriate for simple app, right? And you want Shiny updates to, you want Shiny up to update fast, like twice a second, right? So it looks like a simulation or animation to our eyes. Okay, keeps changing, keeps updating, right? And to take current time as an input, we use this function called reactive timer. So reactive timer takes length of time interval as an input, as an argument in milliseconds, all right? So reactive timer, and then you provide 500. So that will be 500 milliseconds, meaning that Shiny updates twice a second, all right? And then we also use reactive function that we are familiar with. And reactive function takes the result of the reactive timer, all right? Now, the second situation on the right in blue, this is more appropriate for a complicated app. So for example, um, in the first case, we said Shiny updates twice a second. That's very fast. However, what if computation takes a second, right? Then it can't update twice a second because it takes a second to execute the operation or computation, right? Um, so this leads to the user's poor experience. So in order to avoid user poor experience, we would hold off Shiny updates until one particular event. Okay. So in this case, the Shiny holds off updates until user clicks on a button. Right. So again, this contrasts the first case because it's more appropriate for complicated apps, right? And it is meant to slow down updates, the frequency of updates, and it is manual versus automatic in a case where we use the current time as an input, and it uses action button instead of reactive timer, right, to collect that input to trigger reactivity. So in this case, a click, right? So we use action button to collect a click from the user as an input, right? And then we use event reactive function instead of reactive function in order to hold off updates until one particular input updates. Okay, so what that means is here. So reason that we do not use reactive function in the latter case is that if you look at this reactive graph, all these arrows, for example, arrow from lambda 1 to x1 and to x1. All these arrows are solid, meaning that anytime any of these inputs change, x1 updates, x2 updates, and uh, your ultimate output histogram updates. In other words, it doesn't wait until the user clicks on simulate button, right? So it defeats the purpose that we want to hold off Shiny updates until one particular button, one particular event occurs, which is the user click on this simulate button, right? So that is what we see in on the right side, the reactive graph on the right side. This is what happens when we use event reactive function instead of reactive function, right? So all the arrows from any other inputs have been grayed out, right? Only the arrows from simulate is solid, meaning that it doesn't update. The Shiny doesn't update until simulate input changes, right? And that is the concept. And finally, the observer, right? So for observer, again, observer is uh, something that we use when we want the app to do something other than creating tables and graphs, things like that, right? So an example here is, sending a message to console after uh, performing a task, right? So we use observe event function for that. So observe event is similar to event reactive we just discussed, in that an event triggers action, right? So if you look at the example code at the bottom, both function, event reactive on the left and observe event on the right, takes this input submit, right? So in this case, a click, right? A click by the user that we collected from a radio button. We named it submit as an ID, right? So that click triggers an action, and action here in on the right side in the case of observe event, sending a message to the console, and the message is greeting performed, right? And the action on the left side when we're using event reactive is what creating this string hello and the name that user types in to the app, right? And that string is saved under this name greeting. So again, these two functions, observe event and event reactive, they are similar in a sense that in both cases, an event triggers an action, but they are different in the sense that in the case of in event reactive, the results of the action is saved under greeting, so that we can use this greeting in creating an output. So in this case, in the render text function, right? We can refer to greeting. However, in the case of observe event, it's not saved in any variable, okay? Because it's not meant to create an output, such as tables and graphs. So those are the high-level concepts that we are covering in part 2 of chapter 3. And I'll see you in the next video to do some hands-on code examples.